Hello and greetings, programmers. Welcome to today's TCoffeeAndCode. I'm actually running on the M1 Mac right now. So today we're going to look at the ARM on the desktop. We're going to look at Apple's M1 processor running macOS, Windows 10, and we're going to also look at Windows 11 that just came out this week, the Developer Insider Preview. Warranty and disclaimer. So I'm going to start out with a big one. Everything I'm showing you is not officially supported yet. uh, but I think it's still important. I think, at least in my opinion, as developers, part of our job is to push the limits and look at what's possible and poke at the edges. And that's kind of what I'm doing today is pushing the limits of things. So just be aware that is the case. Everything I'm saying, though, is my opinion, subject to change, yada, yada, yada. This is a casual conversation. Experiment with how you can take advantage of these platforms and operating systems. Upcoming TCoffeeAndCode sessions next week, July 7th. I can't believe it's the end of June already. Is Docker, containers, and platforms. This one should be really good. If you haven't been using Docker yet, it's a really great technology. It makes it easy to spin up database instances, deploy your software production and stuff like that, manage things and such. After that, blockchain and NFT. This is the more than cryptocurrency look at blockchain and non-fungible tokens. I think there's some really interesting stuff going on there, so that will be an interesting topic to cover. After that, we're going to get into managing large projects and IDE performance enhancements. This one's going to be a collection of tips and tricks for how to best make sure you're able to compile and work with large projects and otherwise improve your performance in the IDE. Then we have object relational mapping, databases, and data access. This should be a great one. We'll get into FireDAC as well as a lot of the other options out there. I'll be reaching out to some tech partners. A couple of them already are interested in being on there, just to talk about different data access options. But FireDAC is fantastic. I love FireDAC. Always recommend FireDAC. But sometimes, it's nice to have options. That's one of the things I love about Delphi is that there's always a lot of options available there. So then after that, we have REST services, multi-tiered applications, API design, kind of the communication architecture of multi-tier stuff. Unit testing, integration testing, test-driven development. This is kind of all about testing and code coverage and things along those lines. And then code profiling, optimization, performance, and memory leaks. We've touched a little bit on that before, but it'll be good to get some more on there. And then lastly, in August, we have Delphi training jobs, books, and education, which if you haven't been paying attention, there's been a lot of new Delphi books out recently. So it'll be great to get in there and kind of dive into all those different. So I'll introduce myself real quick while Olaf's getting all connected. Just in case you don't know who I am, I'm Chief Developer Advocate and Engineer for Embarcadero, longtime software developer, done quite a few platforms and languages. Delphi is my favorite. My claim to fame is, of course, patenting swipe to unlock back in early 2000s. I don't remember exactly when. Olaf, are you all connected?
Yeah, looks like I'm connected. Can you hear me?
I do. I hear you just fine.
All right. So good evening or good morning, whatever, to you and everybody who's listening. So yeah, and I'm actually running this webinar client session from my MacBook Air M1. This is actually a replacement machine because my regular machine, which is a MacBook Pro, has a display failure and it's currently in service. So I had to have a replacement. So I got myself a MacBook Air and transferred everything from my MacBook Pro to it. And so it's actually the first time that I started GoToWebinar here. So it had to go through all the safety stuff and whatever. So, and well, the finding is the MacBook Air feels faster, more silent, and just at least as responsive as the way more expensive MacBook Pro, which is, well, not really surprising from the news that we all read over for the Apple Silicon stuff, but it's really interesting to see that in live and not on a Hello World something set up. So it's my full development machine on this now, and it's really interesting.
I was actually, so when I fired up so I got an M1 Mac Mini for testing and stuff, and when I first started using it, it was actually, I thought, a little bit slow, and I was like, this is not as snappy as I expected it to be. But after I updated macOS, because it was apparently running an old version, I would say now it is probably probably the fastest computer I have in the house right now. But so yeah, and most everything's, now that everything's updated, seems to all be running fantastic. So, well, that's great.
Yeah, it actually takes a while when you have a quite loaded machine to transfer everything. So in the background, it does a lot of things to get everything in sync again. But the interesting thing, I had the machine transferred and everything. I had it sit on my desktop for a while, and then I took it, well, to the sofa and set up all the passwords and all the stuff where you have to manually do some things. And the MacBook Air, in contrast to the Mac Mini, it doesn't even have a fan, and it doesn't really get warm, not even warm. It's at max. It's just a little hand warm, whatever. It's not hot, not something. And the MacBook Pro, if I let it run for an hour or so, it starts blowing. I mean, it's doing. I mean, it has 16 cores, but they consume a lot of power, obviously. And this M1 in the MacBook Air, it's just amazing that it doesn't even seem to produce heat in any way.
Yeah, well, and I guess that's part of that is the architecture, right? The ARM architecture versus Intel.
Right.
So that's interesting.
Probably because they have everything on a single chip design. It seems that this is really very effective and not producing well, just heat to get the bits and bytes from one place in the system to the other place. So it's, and I have an external display connected to it, which usually means that you have a lot of things going on at the same time. The only thing that I moved temporarily to my old Mac Mini, which is an Intel i7, I believe, is I have a collection of Windows virtual machines, and obviously you can't run native Intel-based virtual machines right now on the Mac Mini, on the M1 design.
Right. Yeah. So I do have the Windows 10 ARM running on the Mac Mini.
Yeah, exactly. That's what I did just recently. I went to the Microsoft Insider program and got myself the Windows 10 ARM installation. And well, I'm usually actually a VMware Fusion user, but I had an old license for Parallels, upgraded that one for $30 or so, and it runs smoothly. It just installed the Windows ARM preview installation just fine. No issues, no glitches, no nothing. If you didn't know it from what you installed, you wouldn't even detect that it's something different, completely different from what we are all used to use.
Yeah, there's a few subtleties because it is a newer version of Windows, so it's interesting.
Right.
Well, apparently, I just updated on mine. Let's see if everything still works. There were a few subtle differences. And then it was interesting that when they had the leaked version of Windows 11 and, of course, the Windows 11 announcement, I'm like, I recognize some of those icons and stuff being different from the ARM version I was running. So this is, I'm not sure, I didn't look at the build version. Well, now mine's updated. I'm not sure if you got the update that just came out for this or not applied on yours.
Yeah, that could be. I believe I have a pretty new, or actually the latest Windows 10 RM build, and that really looks, in my eyes, identically to the regular Intel-based version. It also comes already with the cool feature that Microsoft came up with, which is the weather forecast in the taskbar, which is a feature that they probably worked 10 years to get it flying, but it's the same. I mean, I honestly, I didn't think, or I didn't believe that it would run that smoothly. I thought it's a bit of a well, Area 51 experience, but the only thing which it didn't detect could be because of a parallel setting. It was my language. I had to go manually into the settings, download the German language packages, and then even that worked. So I could just switch to a different, or from English to German in my case, and from then it looks like the same.
So
I mean, I don't have all the programs on it, so, but still.
wow, my oh, it just crashed. My Windows 10 VM just updated to Windows 11. Oh, there we go. I now have Windows 11 on ARM, which yesterday I looked into this and it wasn't available. And apparently over the night it rebooted or reinstalled. Okay, well that's going to be interesting.
Yeah, I actually I read a couple of user comments that reported the exact same thing. On my machine, for whatever reason, it says my hardware doesn't meet the minimum requirements, which I believe is either the TPM module, which is missing, or something with the DirectX 12 requirement that Microsoft introduced, or they just came up with something that lifts the minimum requirements.
That might be.
Or it's the Mac Mini.
So I did discover, let me see if I can switch over to, all right, so where's the window? I can't switch tasks for some reason. Okay, so I can do it on this one here, which is just a, in order, if you're running parallels, to get the TPM module, if you come in here and you click the plus, oh, it's not available here. All right, on the Intel Mac, if you click plus, you have a TPM module as an option to add, which I had to do on my Intel computer, which I can jump over to show that, to add a TPM module. But yeah, just for some reason, this one just updated to Windows 11 now. So I guess we're going all in on Windows 11 on ARM now. I was trying to figure out how to do this, and yesterday everything I was reading said it wasn't possible. So here we are, Windows 11 on ARM, and Delphi should already be installed in here.
Well, I have Delphi installed, of course, one of the newer versions, and it just runs, which is amazing because I'm pretty sure that you guys didn't come up with a RM version of Delphi, so it runs on the emulation layer on Windows RM, which means it's actually executing Intel code, which is emulated to RAM or ARM code in Windows 10 ARM, which is interesting that it really runs that fast. I mean, we know all that emulations are not that efficient. I mean, we all probably went through that when we tried to install the Android emulator on Windows or even on the Mac, which never really worked in a usable way.
Yeah. there's a lot of interesting technology behind it. I was reading into the details of it, and they had if I remember correctly, they translate the instructions and then cache the translation. So the first time it tries to run the Intel instructions, it translates them into ARM instructions and then saves that translated instruction. So it's essentially just translates it into an Intel instead of ARM, or ARM instead of Intel instructions, and then uses that translation. So that's kind of crazy, and yeah, it works.
And by the way, Apple does the very same thing with Rosetta 2, which is basically doing exactly the same thing for Mac applications. For the Mac, they went a little bit different. They introduced the universal application format, which means there is a package that bundles, or if your application already supports M1 natively, you can actually bundle the M1 binary with the Intel binary. So depending on what you put on the machine, Apple executes M1 binaries natively or emulates from Intel code to Apple Silicon code, which works very well as well. I mean, I have tons of applications on my productive machine, and I didn't find any application that didn't work for now.
All right, so let's go ahead and I'm going to make a Delphi application here and just see how things go on Windows 11 ARM. So this is unsupported hardware and an unsupported OS before we go anywhere, just to make that clear to everybody. So if things go sideways, that's what we expected to happen. If things work great, we'll be pleasantly surprised.
Are you actually sharing your screen?
Yeah.
Because I only see a black screen. I did see the slides that you presented, but I don't see anything on that thing right now. Let me see if that is setting. I might have to reconnect once again, because
try reconnect.
Okay, I'll be right back.
Okay. Hopefully everybody else sees my screen. So there's a question here about if the start menu or the buttons at the bottom changes. So if I click here on calculator, we'll see that this slid over as the calculator showed up. And then when I close it, it'll slide back. But you can also come here and say taskbar settings and go down to behavior and change it to left. Now, in my opinion, not only is this what I'm used to, and I like things not moving around as much, although I do like that you can rearrange these easily, which is nice. So especially if you have like two open, you can just say, oh, there we go. Let's put them in that order. But from a usability point of view, oops, I've opened too many things. So, all right, go away. From a usability point of view, if I move my mouse down to the lower right, this point right here is infinite, right? So I can't go too far to the left and I can't go too far down, and I'll hit the start button. So it makes the start button easiest button to hit, easiest place to hit, because no matter where I'm at in this area here, I can keep going left or keep going down, I'll hit it. So, yep, everybody's saying they can see my screen. Okay, great, thanks. And you are already registered for future TCoffeeAndCode sessions if you are registered for this one. It's just all one big series. You'll keep getting emails about it. Put the ones on your calendar you want to attend, and we'll see you online. So anyway, I can change this to be there, and I've made a application here. Button, list, box, edit. I'm sure we've all seen this demo before. If you haven't, oh my goodness, you're going to be impressed. We'll say list box one dot items dot add edit one dot text and run this. There we go. That works. Oh, look at that. I got rounded corners already. Automatically. Oh, nice. That was one thing I wasn't sure about. I'm probably see some options for that in a future release of Delphi, but let's debug this now. Set a breakpoint. And there we go. That worked as expected. Awesome. So when I tried this before, I couldn't get 64-bit to debug. Now, it's only recently that Microsoft added 64-bit support to Windows on ARM. So originally, Windows on ARM only would run 32-bit applications, but now it will run 64-bit applications, or at least it's supposed to. So let's run it. There we go. It's running now as 64-bit. It works. So let's try debugging it. When I tried this before, I couldn't get anything to debug, and I thought that was I'm pretty sure it's a limitation of the of Windows. Oh wow! Oh, yes, look at that. It is debugging Windows 64-bit applications on ARM. That is amazing. All right, I'm pretty excited about that. That was probably the first time that happened because I just tested this yesterday and I couldn't get the Win 11 on ARM to work, and I couldn't get the Windows 10 on ARM debug. So very, very cool that that's working now. So I am running, just so everybody's clear, 10.4.2. I'm not showing some pre-released version of Delphi, as you can see here. So if you have 10.4.2, see there's a question here. If you're using the MacBook screen, not external, is there enough real estate to work comfortably in the Delphi IDE? Yes, there should be. So I would assume so. Maybe Olaf can speak to that better when he gets back on here. But
yeah, I'm back.
You're back? Yeah. The question is, if you're running a MacBook, does the screen have enough real estate to work in the IDE?
Well, I'm using the 13-inch version of the MacBook Air, and to be honest, right now I have the Parallels screen running on my external screen. So let me see what happens if I move that to my primary screen, which is the MacBook Air screen, and see how Delphi looks there. I'm actually just trying to run 64-bit debugging, which seems to have a little problem in my case, which might have to do that I'm using something which is not something we can show publicly.
I think it's a limitation of the Windows because mine was not working until it updated. So it was a limitation of Windows 10 that you couldn't debug Windows 64-bit applications. And so apparently Microsoft's fixed that.
Yeah.
This is, just so we're clear, we're really pushing the edges of things here, people. So, okay, so Roland said, can you repeat what you're running on right now? This is, let me pop out of here or go about this Mac. This is a Mac Mini M1 running on Apple M1 processor. So I'm running Big Sur. I'm not running the beta. I have the beta, macOS beta in a virtual machine, but I didn't want to install it yet because I didn't want to break things. And then this is, I don't know why these icons aren't showing up here. That's really interesting. System about Windows. So it's called Windows 10 ARM because it was Windows 10 ARM up until right before this webinar started. It is Windows 11 Pro, update 21H2. There's the build running on Apple Silicon. I noticed it says 1 gigahertz. It's not running at 1 gigahertz. But
well, the the 1 GHz thing is something I see as well here. So that seems to be a limitation of the Windows 10 or 11 ARM support that they don't get, or it might be something from Parallels. So
Yeah.
it's the same thing I see here. So I'm running on the MacBook Air M1, so very similar to yours. The only difference is that I have an integrated screen and you not.
Yeah.
And I don't have a fan.
Well, I don't think the Mac Mini has a fan either. I think it's running fanless as well.
Uh,
I'm not positive, but yeah. Okay, so and I only have two of the cores. So this has got 16 cores, I think, in here. In the Mac Mini has 16 cores in this M1 processor, but I have two of them coming into the virtual machine. Should have put more in here. And so the
in
question
your
was,
system.
what's that?
Yeah, go ahead.
Oh, okay. The question was if the CPU view worked, and so here is the CPU view, 64-bit debug CPU view, and this is x86 CPU debug code. Let's try the 32-bit view debug CPU view. So I was in a meeting this morning, and we actually discussing the. Someone asked about if anybody tested on here yet on the Windows 11, and I'm like, oh, I just installed it. So this is, you guys are seeing the absolute cutting edge here. Sorry, I'm doing view debug CPU window, entire CPU. And so there we go, 32-bit x86 code. So the translation that happened to ARM code is not visible here. So it exists both as ARM and x86. So the ARM version, the translated version, is a lower level below what I'm able to see here. But wow. Okay. So there's a question about if I can run Android on Windows 11. Now, from my understanding, is that is not been at that support's not available yet, but it is something that Microsoft has been working on for a long time, and they actually had a beta of it a while back, but they took it out. So I'm not even going to try that, but it is coming. That's one of the features that's coming to Windows 11 is the ability to run Android apps natively.
Yeah.
But semi-natively. I don't know how you want to say that because it's not going to be completely natively. Although since I'm on a ARM processor in this case, it would be semi more natively. I don't know. How does FireMonkey 64-bit perform? All right, I'll fire that up. Were you going to say something, Olaf?
I have a simple Hello World application running here, which is running fine in FireMonkey on my ARM system here, and it's compiling fast, and I don't really see anything. Well, which if nobody told me this machine that I'm sitting in front of would be an M1 ARM Windows whatever system, I wouldn't detect that. And the virtual machine that I'm running on Parallels here, by default, just took 2 cores, which is usually not what I do. Usually I have 4 cores and assign like 4 to 6 gigabytes of RAM, whatever. And it's basically just a very minimalistic machine or setting here, and it's still just performing. And even FireMonkey, I don't see anything strange. I didn't try, or I didn't play with the GPU features, metal, whatever.
Let's see. There is a yeah, it's in here. User interface. I'm trying to remember which one it is that has all the controls on it. Is this it? No, that's not it. I can run this one anyway. Run it on. So this is a FireMonkey application running here on. Oh, that's an interesting painting issue. That's odd. Oh, it fixes it and resize. Something wasn't painted right the first time it came in. Let me find what I was looking for. I thought there was an open sample button from up here, but maybe I'm remembering wrong. Open sample. Object Pascal. Multi-device. It wasn't media. No, it was in here. User interface. Oh, controls. There it is. Trying to so Parallels only grabs right now. Parallels is only set to have 2 cores. So I go up here and look, edit. Let's see, view file. Where's it at? Control center, CPU. It's only set up to 2 cores. I could try rebooting it to give it more cores, but right now it's only got 2. I could give it up to 8. So it is an 8 core system.
Olaf is asking what the biggest screens that the MacBook Air is sold with. It's actually the 13 inches screen, and if you need a bigger screen, you probably want to wait for the MacBook Pros, which are coming out probably in this fall.
Yeah, well, honestly, so I have an old MacBook Pro, very old, not very, very old. I guess it's probably maybe 5 years old. So I guess that is very old for a computer. And the Mac Mini that I got, and I was thinking I could theoretically travel with this and just use the
Yeah.
use the Mac. And oh, I don't have Android set up. Let me set it to Windows.
And I just moved my virtual machine to the primary screen of my MacBook Air, and it looks good for me. I mean, it's not the large screen setup that you want to have as a developer working on it 24 hours a day, but it's okay. I mean, it's not too tiny. I would say it's workable if you are saving space and need something that you can travel with. It's perfectly fine. And while in the office, you just connect your big screen, and it seems it can handle large screens. I have something like a 2.5K screen. It's 2,600 by 1,400 or something, 1,600. So, and it's crystal clear, definitely.
Cool. This is what I was looking for. All right. So let's run. This is going to be 64-bit, and I'll debug it and see what happens here. Now, this is running in a virtual machine on, just restate things. We're running in Windows 11 in a virtual machine on Apple M1 ARM silicon. So completely not officially supported platform. Let's try the 3D effect. Actually looked really good from my end. I don't know how well it went through the GoToWebinar screen sharing, but everything looks good here. Let me put a breakpoint behind that button there. Breakpoint. And go back in and click the button. And the breakpoint stopped. We have some sort of, there's a bad line feed in here someplace. I can fix that. And we're debugging just fine. Windows 64-bit FireMonkey, and I would say honestly, this actually is compiling quicker than my desktop in the other room.
Yeah, it's really smooth, and we all know that compiling FireMonkey may take a little while, but I really see a fast machine, and considering that it's actually not even half the money that I spent on my MacBook Pro, it's crazy.
Yeah, I am pretty sure I'm going to switch to this full time now. Honestly, okay. Let me see if I can get
Yeah.
the deploy to Mac to work here. So let me switch over to the Mac, which I gotta come on. For some reason, it doesn't like going on a full screen. There we go. PA server.
So the decision which machine is the best for you, because Alf is asking. I mean, it depends on what you're doing. If you are 99% sitting in your office, then you probably don't need a laptop. So a Mac Mini is probably the well, most economically choice that you can make, and connect a large screen to it, and you will be fine. If you plan to travel a bit, or if you are the type of guy that moves from the office to the sofa frequently, then a MacBook Air is probably more that what you would want. And like I said previously, the real estate that you have on the screen is actually good, and that was, I didn't know, when scaled up to 200%. I just scaled to 100% in Windows, and it's I'm actually wearing, I have to wear glasses, and the resolution is apparently extremely high. So depending on your side, on your glasses, I would say the MacBook Air in 13 inches is just amazing, even for those cases where you use it as a full machine.
Okay, so someone asking about FireMonkey skins. So this is running on macOS.
On Rosetta.
Yes, under Rosetta, exactly. And I'm not debugging. We debug it. Oh, I didn't fix that line feed issue. Oh, okay. So it still can't debug on Rosetta. That makes sense because, yeah, that makes sense. But Windows 11, you can debug on Windows 11. You can't debug on Mac OS 11 yet. Now, Rad Studio version +1 will have official M1 support. This is running without M1 official M1 support. It is running with the running through Rosetta or through the interpretation layer on when I'm running on Windows. So we're running again unsupported hardware and software operating system versions here. Style book. All right, let's put a style in here. Oh, let's see. I got to go. I don't have the shortcut for it.
There is a question from Sean regarding the cores on the M1. The more expensive version of the M1 has 8 cores, and correct me if I'm wrong, I believe 2 of those are well, energy saving ones, and Parallels doesn't seem to make differences here. So you only can choose a number of cores to assign to your virtual machine. So I believe that's something that they will have to figure out how to promote that to the virtual machines.
There are energy saving cores, but I think the M1 only comes in one configuration. There's just the M1. There's not the.
Yeah, you're right. The GPUs are different numbers, right? You're right.
Yeah, it's the RAM and and storage are the places the variations are, because this is really the first iteration of the processor. I kind of thought there'd be an M1X or something that came out with the last update, but there wasn't. So there we go. We got styles. So now we'll run on macOS with my favorite style. At some point in the future, I will definitely revisit this with the beta version of the next version of Delphi when that's ready for sharing. But yeah, that looks really, really good. Yeah, it looks perfect in my eyes, looking at the screen directly here, and I'll run it on Windows as well.
It's actually four high-power CPUs and 4 efficiency or low-power CPUs.
Okay.
Looks very fluid.
Yeah.
Even through GoToWebinar, which usually adds some lag and flickering and
Oh, that's that. It's just not. There's a box there. You still see it. Okay. Very cool. All right. Let me look here on the questions. Is there any? So there are a couple of slight things. Is it possible to run Rad Studio on M1 only using Parallels by now, not VMware? Does it run as pure virtual machine or as an emulator? Okay, so to reiterate, I am running a M1 Mac running Big Sur, and this is running Windows 11 ARM inside Parallels virtual machine. So the Windows 11, it's Windows 11 ARM, not regular Windows 11. So it's Apple Silicon, and yeah, so it doesn't. So the way you can tell that it's running on Windows 11. So I was trying to poke at this and figure out how to tell. Is if there's an API call I haven't poked into yet. But if I come here to the program files folder, I have a program files ARM directory. And if the program is ARM architecture, it's supposed to install in this directory, but I had a couple programs that I was experimenting with that I knew were ARM that still installed in the program files folder. So it's really, I think, amusing that this is 64-bit Intel, this is ARM, and this is x86. So in the future, if they they'll add a RISC folder, but 64-bit Intel will still be the program files plain folder. Yeah, see, this morning it upgraded. That was my old Windows is still there. Interesting. Okay. So is it possible? So right now, I don't believe VMware has support for the ARM chip yet. It's only Parallels, and I don't know about VirtualBox. So, but yeah, it is virtualizing the operating system, not so the Parallels does not virtualize the CPU instruction set. It just virtualizes the operating system. But so this is Rad Studio running on, which is x86 code, running on an ARM architecture being virtualized, so being translated by the Intel translation layer that Windows includes. So hopefully I answered your question. So if you have an Apple Silicon now, you can install Windows 11 in Parallels and run Rad Studio 10.4.2 just fine, and everything. The only thing that hasn't worked for me is the debugging Mac 64-bit on debugging 64-bit Mac OS, but everything else seems to work fine. I was going to do Android. So I did Android before and it worked fine, but let me go ahead and fire that up right now. Is there any other questions here? I totally went off the rails of what I was planning to show because this updated on me at the last second.
Regarding the emulation of ARM and Intel command sets, from what I read from VMware and Parallels, it seems that there is so far there are no plans to produce some kind of a emulation layer or something. So for now, it seems like they are not investing into offering something that would allow us to run Intel-based Windows virtual machines on the ARM processors. So it's going to be all down the RM, virtualizing.
Yeah. There is another virtual, what is it? It's like QEMU. Yeah.
Right. I believe it's an open source thing or something, and it's incredibly slow from what I read. So I've seen demos where they try to show that it would work, but in the end, it's not really usable because the emulation layer is just too slow.
Yeah. So this one, this emulates. It says fast, relatively speaking, but it does emulate the CPU itself. So if you wanted to run in theory, I don't know if anybody's done it yet. They probably have. It probably works. I don't know how fast. You could run a x86 version of Windows on Apple Silicon with QEMU. But yeah, I don't think anybody else. Well, I don't know. You never know with VMware or Parallels. But yeah, from what I've seen, they're really focused on the virtualizing, allowing multiple OSs, but not trying to virtualize the instruction set, because both OSs, both Windows 10 and Windows 11 ARM and Mac OS ARM, virtualize the instruction set on their own, and they do a better job than a second virtualization layer. It's interesting that there is not a. Is there any roadmap for Embarcadero to support ARM native applications? Yes. So let me bring that up here. Studio roadmap. I spelled it wrong, but still got the right place. So this is the current roadmap. And right here we have, let me go down to the detailed one. macOS 64-bit ARM compiler for Delphi lets you target upcoming Apple Silicon. So the next version, which if you're on update subscription, you will get upgraded to, but you'll also be invited to the beta in the near future when that's available. There will be an update subscription beta, and actually they have, if you're on premium support, you can get on the beta earlier. So if you are interested in being able to target Apple Silicon natively as soon as possible, get on premium support. Or otherwise, just get on update subscription, and you'll be invited to the beta in the very, very near future. Yeah, Mac Mini is not expensive. Keyboard and mouse PC purchase options. So you can get, like I was saying, I don't have any plans to travel in the near future, and who knows if I will travel again. I was actually thinking about getting some telepresence device or something so I can attend conferences flying. I would love to fly, and I know some people are, but I just, so many conferences and events and so many places are still being shut down for things. So uh, yeah, I don't know that I'll be traveling again in the near future, but the Mac Mini is not expensive. Keyboard and mouse, you can get portable or very affordable options. And if you have an old laptop, you could very easily just VNC into it and use it just fine.
Yeah, and the Mac Mini uses or can use every mouse and keyboard and screen. You are not tied to or bound to Apple devices if those are too expensive.
Yes.
And so every screen would do, and it has a lot of connectors. So if you want to save money, just go for the Mac Mini. The iMac, of course, is really cool, but you have to pay for it.
So the question here, Scott's saying, hypothetically, if there was a RAD Studio that was macOS and M1 native, so I'm assuming you're saying a ARM compiled version of RAD Studio, which is not on the roadmap, wouldn't it likely build Intel Windows apps faster than RAD Studio on Windows does now, based on what you're seeing with performance in these experiments? Yeah, I guess so. So from my understanding, is the performance difference between ARM compiled versus x86 compiled running through the emulation is not a huge difference. There is a difference, and it is worth targeting the native silicon, but I wouldn't say it would be a big enough difference to really be like a huge of a deal.
Yeah, and like you said, the M1 is the very first iteration of Apple Silicon, and all the comparisons that we make are against at least an i7 or even an i9, and the comparisons are really bad for Intel right now. And once Apple comes out with the second iteration, which is probably not slower than the first iteration, well, things could go really, really sideways for Intel then. I mean, if that is really the very first thing that they played with, well, let's wait for the real thing then. So yes, if there was a RAD Studio compiled for Apple Silicon, it would probably compile a little bit faster than what we see right now on current hardware. And if you go into the Geek benchmark statistics, they have comparisons even for the Mac Pro, the expensive beast of 26 cores. Of course, if you have 26 cores running at the same time, they are faster than an M1 for sure. But if you compare the single thread benchmarks, then even there, the M1 is faster than the Mac Pro.
Yeah. Trying to go through the questions here. There's a question about the scale functionality I was showing earlier. There is a scale by in VCL. I've used it before. It is a little bit different than the scale in FireMonkey, but you can do something similar for that. Made it open rough time scale. Martin's asking. I really can't comment to that. It is probably fairly soon, but watch the blogs.embarcadero.com. Watch your email. There should be some details on that. Using Delphi on Windows ARM VM seems to be faster than I thought. Definitely a good choice to replace old Intel Mac. Yes, yeah, it actually, yes. Once everything's updated and working, I would say, yeah, this is okay. So yeah, I'm not targeting. This is these are all Intel compiler options I'm running right now, but the operating system is what is translating that to ARM version. Running.
It's the project, how do they call it?
Okay. Looks good. If there's something else that you'd like to see here, certainly do put a quick comment in here and I will do that for you. Yes. It's supported OS and hardware. Windows 11 ARM. And again, if you're just joining, I am showing unsupported OS and hardware. But it all seems to work as good as I would expect. All right. Microsoft currently does not sell licenses of Windows 10 ARM for virtual machines. I would expect they should be doing that in the very near future. They did announce that they're going to start selling, they've teamed up with Qualcomm to start offering a development box that will have Windows 11 ARM at this point installed on it. So I would expect in the very near future they will have that. But you can get the preview build easily enough to do that today.
Right. And on some blog from Microsoft, I read that they are going to lift the requirements on virtual machines. So the DirectX 12 and the TPM thing are probably not going to be enforced on virtual machines. That's what they are saying on a blog. So that means for me that they are planning to release for virtual machines or offering licenses.
Well, and this virtual machine does not have a TPM module in it because that's not supported on the Parallels ARM version of Parallels apparently. So they may have already removed it.
Yeah, and even if they seem to remove that requirement on the Parallel block, they write that they are planning to support or implement a virtual TPM module in some way, which could be something that they might cancel when Microsoft says, okay, we don't need that on virtual machines. So on either end, they are working to get this thing running on virtual machines. And in regards to VMware, it looks a little bit like that they are quite a bit behind. They have a lot of things on their side that they are planning to do something and that they want to do something, but they don't have even a beta from what I see right now. It seems to be that that Dell, who owns or owned VMware, they sold it, or I don't know, they dislike VMware, and that probably hurt their development process in some way.
Yeah. So VMware has really been focused on the high-end enterprise architecture for a while, and actually has not been updating much on macOS lately. So I'm not terribly surprised. Actually, I for some reason I thought VMware stopped supporting macOS altogether for a while, but because Parallels was getting out much faster than they were. But they're working on it again. Honestly, so I'm going to wax theoretical, philosophical. I'm not sure what the term would be. I expect that ARM processors are going to eat everything up in the next few years. Everything's going to be, you're going to see ARM everywhere. You're going to see it in the servers. You're going to see it in the cloud. You're going to see it on all your desktops. And there's a few reasons. One, Intel has stumbled big time. AMD is eating their lunch in the high-end sector, and right now, and Intel's also, secondly, then there's the fact that ARM is so much more energy efficient than Intel architecture is, the x86 architecture. And people are more and more concerned about those sorts of things, about climate change, energy consumption, and things like that. And ARM is so much more energy efficient. It makes sense. And the third thing is, in the US, there was a bill that they're going to fund, because of the whole chip shortage and the fact that they're having a hard time getting chips, the whole supply chain chaos. They just signed a bill that I can't remember how much it is, but I want to say it was billions of dollars is going to go to domestic chip production to a number of companies. Now, right now, there are only 2 companies that produce x86 chips. There might be some other exceptions, but there's Intel and ARM. But Apple, Google, Amazon, and a number of other companies have already said they're going to start producing their own ARM chips. And now they just got a huge infusion of government money to build chips. They're going to build ARM chips. And so everybody's going to be making ARM chips, and pretty soon they're just going to be everywhere. So ARM is about to just eat the world right now.
Yeah. And it took probably Apple to demonstrate that it really works if you do it the right way.
Yeah.
It just took Apple's money to invest and say, okay, let's spend a couple of $1 billion and let's see where we are going. And apparently, they found a way to make it so much more efficient than the standard architecture, so that now everybody says, okay, we can do it as well. And I believe that's the reason why we see so much movement on the Microsoft side now. I mean, they had the ARM support for quite a while already, and it never took off. But now, suddenly, they probably bought a couple of Apple M1s and tried to get it flying.
Oh, Red Studio sees it, so it doesn't even matter. Oh, what's the error message? Oh, it's not on iPath. Okay. So Rad Studio sees it, Android 32-bit. I don't have something to share my screen, but we'll just do the basics of it here. You've all seen Android apps running from 10.4.2. The main thing is just that we can do it from. Jay Kelly says ARM RISC processors have always been faster than Intel CISC processors, but they were always so expensive. Yeah, so ARM's come down in price. And the other thing that's really interesting that's going on is Intel is looking at buying, I can't remember the name of the company that does RISC-V architecture, which is a whole nother CPU architecture. So Intel might start making RISC processors. And so, yeah, it's about to get really interesting. So, yeah, this all worked on there. Let me put a breakpoint in here. I'll just put a button on. Which form is that I'm starting on? Let me get a different one. Sample. Oh, and I will test databases as well. I heard there was some issue around databases. Okay. Let's run this on Android, 32-bit. And I'll put a button down. That's always the easiest way to. Okay, let's put a breakpoint. We'll do a show message. Show message. Ah, what am I hitting? Keys, wrong place. I should be using the asynchronous version, but whatever. All right, breakpoint, debug, deploy, Android. Is there an ARM CPU architecture slide to better understand the differences between ARM and Intel?
There are probably quite some of these slides and explanations.
Yeah, I don't have anything. I was planning the show today on that, but if you go look around online, I'm sure you can find something. And yes, ARM. So ARM is a RISC architecture, but it is a specific RISC.
Exactly.
There's also RISC-V,
exactly.
which is a third architecture. Then there's Intel x86 and 64-bit. So that's 4 different architectures. You have Intel x86 and 64-bit, which is actually AMD's standard for 64-bit because Intel's Itanium lost. So there's AMD 64, Intel x86 32-bit, ARM, and RISC-V, 4 different architectures.
And just to understand the basics, a RISC system means a reduced instruction set CPU. So it has fewer instructions. And because it has fewer instructions, these instructions can run faster, in very simple words. The CISC architecture means a complex instruction set CPU, which means tons of instructions which are very specialized. Every instruction has a very specialized meaning or means, and to execute those, it takes a little longer, which is the core difference between RISC and CISC. And ARM is a company that basically came up with a blueprint of a standard RISC implementation, if you will. So ARM never sold CPUs. They never did. They only came up with the idea, with the design of a processor, how to do that. And then companies like Apple or other companies like Qualcomm, for example, they licensed that master design, that blueprint from ARM, and built their own architecture or their own implementation. And Apple started with the A processor series, which are in the iPhones, and now they took what they learned from that into the M1 processor, which is also using licenses from ARM. And CISC, complex instruction sets, are, well, is what Intel and AMD are using for their x86 designs.
Right. All right. So Chris is asking me to spell this out one more time. So there's 2 CISC ones, which are AMD 64, which includes x86 compatibility, and Intel x86. Then there are 2 RISC ones, are ARM and RISC-V. So there was a 5th architecture called Itanium, which was Intel's version of 64-bit, but it wasn't backwards compatible. It wouldn't run x86 code, but AMD 64 was backwards compatible, and so that's why it beat out Intel's Itanium.
Yeah. It's when we saw the IA32 builds of Windows.
Yep.
They actually had Windows built for it long time ago.
All right, so we debug or compile Android 64-bit. We saw that 32-bit works here. And we'll try debugging it as well. So yeah, there's RISC is a architecture type, and then there's two implementations of RISC. There's ARM, and there's a few implementations of ARM, and RISC-V. So that is a little confusing, I suppose, but yeah, there's differences there. Yes. Yeah, there's big Indian versus little Indian as well. There's a number of differences between them when you get down to the nitty-gritty details. Okay, so I just compiled Android 64-bit. Did I hit debug? Oh, it didn't. I thought I hit debug. It doesn't look like it launched it in debug mode. Interesting. Let me try again. Oh, it is? Okay, it's just still connecting. Okay.
And the performance increase that Apple apparently was able to implement with the M1 is not just because it's just an ARM system. They, over the years, had the experience or gathered the experience to build highly integrated chips. So they were able to build a system on a chip design for the M1. So everything, memory, GPU, CPU, and even the machine learning unit is on a single unique chip, and that makes the throughput that massive, and they can reach that high performance level that we see right now, and that's the reason why it's so successful.
Yeah, exactly. That they have built. So yeah, in the past, the Intel or the hardware manufacturers would create the CPU, and then the OS manufacturers and software manufacturers would then create a development tools and software around that architecture. But what Apple's done by bringing that in-house is they're able to customize the CPU to a degree to give their software the best possible performance. And that's kind of a lot of what we're seeing here. There is flexibility in the way ARM is implemented in the ARM spec that you can customize it quite a bit. And so that's what they've done. It's still ARM compatible, but it is also customized, as Olaf was saying, with the machine learning and stuff like that in there as well. Modern Intel and AMD processors are actually, so inside the, there is, it's weird that they, at some point, they made the transition in the actual silicon to a CISC in the silicon, but then they have this translation layer that still allows it to run CISC. But so a lot of the differences are kind of academic to a degree, but then you look at the actual performance and such, and that's where, we're essentially talking about right now.
Yeah.
All right, so there was a question here about running Interbase and FireDAC. So let me, let's try this here. New. All right, so I'm running Interbase now. It's not running. And yep, it's running in the IDE. So I can now put down a grid. And bind it all up. Oh, I picked a really boring table. I'll try a different table here.
Yeah, but it connects. Obviously, the Interbase process is running in the background, and
Yep.
again, it's all running on a ARM system.
Yeah, exactly. I'm just never happy to do simple demos, which is why I'm doing this webinar today. Connected, true, active, true. I tell you what, if you're all Delphi developers, C++ developers, you still to today doing this demo for somebody that is not used to Delphi or C++ Builder blows their mind. The two demos I did, right? The list box, edit box button, and this is so much harder and so many other tools out there. It's just crazy. So yeah, Interbase works fine. Let's try IB Lite. Oops, I gotta remove this guy here. IB Lite. Oh, there's no connection there. I'm sure it works. I'm just probably doing it wrong. It should work. Let's try SQLite. Yep, SQLite works. Oh, I already got that. Field editor, add all fields. And after true, especially doing this with a REST service. I can't tell you how many times I've done that with somebody that's not familiar with our products and shown them how easy it is to make a REST service and display the results on the screen, and they just lose their mind. Yeah, there we go. SQLite. So yeah, everything looks like it's working normally, as good as I expect, or better than I'd expect, honestly. Wasn't there a CPU that allows you to write your own microinstructions? So yes, it's called a. What is that called? The Cross.
Yeah, there was. It's quite a while ago that they came up with that.
They're still around.
Write your own.
Get something of the day for it, but I can't remember what it's called. It is. Someone's going to mention it now in the questions here. There's a. It's a chip that you can get that you can upload an instruction set to, and it'll run. And then it's not as fast as if it's built in natively, but it is FPGA. Yes, thank you, Jeff. FPGA per Jeff. Thank you. That's what I love about this format is that if I can't remember what it's called, somebody else can tell me. Field programmable gate array. This is it's pretty cool. It lets you, in theory, you could get an FPGA and you could load up a x86 instruction set. You could then load up a ARM instruction set and switch between the two on the same hardware. It wouldn't be as fast as regular hardware would, a regular CPU would, and it's way more expensive, but it gives you that flexibility. Why not use the wizard, or do you already know it won't work on Android? The new, I don't have those installed. I'll install those wizards. They work fine on Android. The low-code wizards. Could install them, I guess. There's Get It Package Manager. I'm blind. Interbase roadmap has plans to have ARM native 64-bit support macOS too. All right, great to hear. Sriram's on. He's the architect on Interbase. Doug's saying, great, now I have to run out and get a Mac Mini. So the Mac Minis come around at different prices at different times. You can usually occasionally get some good deals on them. So sort by date, subscription only. Oh, the TPM is, why don't I see are they not subscription only? Thought they were. They were, I just passed them. Firefox wants to update, of course. I clicked the wrong thing anyway. All right. But I was going to jump out here. TPM module. No. I have 2 instances of Fire. I have to figure that out. I think I have Firefox installed twice. TPM module CPU is what does a TPM chip do? It's a trusted platform module. There it is, trusted platform module. It stores the encryption keys used for secure boot and BitLocker.
It's similar to what Apple has with a T2 chip. It's same thing. It has a secure enclave, so you can store things in that chip that nobody is basically meant to explore, or it's a safe area where software on your computer cannot have access to it, so that malware and stuff cannot touch your most important things, which is like the encryption key for BitLocker.
Right. So Chris is saying the FPGA is not what he was referring to, but there was a CISC processor that allowed the OS to provide its own instructions to help with the CPU-OS integration. So there is, CPUs are incredibly complex beasts, and there is, so like there are ways that the OS can interact and write to some CPUs, but I don't know the details to that offhand. Other. That's not it. Nope. What am I missing here? Multi-device. Oh, okay, there it is. FireMonkey app. Wizard. All right. I honestly have not played with this since a beta. Name. So let's see what happens. All right. Run it here on. So this, if you haven't looked at this yet, David Millington did a webinar on this recently, and I honestly haven't watched it yet. I apologize, but you can go check that out for more details. I did play with it, like I said, in the beta quite a bit, but it's been a little while. So here is the screen. I should be able to just log in right with anything. Okay, so I don't have any of the screens defined yet, but you could context list is supported by Windows, and then here is the navigation as well. Theme, light, dark. It's actually pretty cool. The most interesting bits are in the way the code and the way it's all architected. It's extensible. You can decide what fields to include and what not. I have not tried deploying this to a mobile device, so let's try that. Oh wait, no, I haven't deployed this to mobile before. I apologize. In the beta, like I said, it's been a little while. But honestly, that's one of the biggest problems I have in working in Embarcadero is I can't remember what stuff is coming, what stuff is out, what's in the next version, what's in the version after that. I think I have to go into the deployment manager, project, deployment. Is Interbase SQLite, Interbase Ivy Light in here? All right, let's add that. That featured IB to go. Or we want to add Android 64 because I'm on 64. Okay. I'm not sure if I have to deploy the database or not. Oh, I don't have a way to view the screen. Shoot. Actually, I think I have Interbase installed on my phone. All I need now is somebody to try and connect to this while I'm doing this, since I've just showed my ID. Let's see. I have to approve the connection though. Haha, look at that. Okay, so it needs permission to access storage for the database. Okay. And apparently I'm missing the permission for the context list. And the database file didn't get deployed. So let me deploy that. I thought I might need to deploy that. Add. I'm not, honestly, you know what? I probably don't know the right folder to deploy it to. If I deployed the database file to the right folder, it would work, but I don't know the folder and I could consult the docs. But otherwise, that all seems to work. So whoever was asked about that, that does seem to work. I used to have I was working at this one place that we built software for probation officers and like probation and parole and like detention centers and stuff like that. And my boss had this really bad habit, as if he had a customer on site talking to him for a meeting, he would come in to my office and say, Jim, can you show this new feature that we have coming? And I'd be like, I don't know if it even compiles right now. So I was always doing live demos. I kept saying to myself, I'm going to have a separate instance set up and running so that when that happens, I could do it. I never did, just because, you're always changing stuff so fast. So, cool. So Chris just put a link into the in Pentium Xeon processors to have patchable microcode, at some point used by hypervisors to tune the performance of the system. Yeah, I think there is still some of that is available now that you can do some some things. Oops. Honestly, so that's one of the problems today is that our computer systems are becoming so complicated. It's like the fact that the internals of the x86 are RISC, but they have the CISC layer on there. It's like it's so hard to find any details about that because it's just such a huge so complicated. Is there let's see if I can find a ARM versus x86 versus RISC. Oh, there's also MIPS. So annoying. Oh, this is the licensing model. Yeah, that's not very useful. Anyway, if you go out and dig around, I'm sure you can find some interesting stuff on it. I'm not going to dig around too much on that right now. I will bring up, let's see. So if you are interested in the upcoming beta for Rad Studio Next, do stay tuned to the blog site, blogs.embarcadero.com, and watch your email if you're already on update subscription. If you're not on update subscription, get on update subscription. And if you're really anxious, the premium update subscription is going to be faster for that. Yeah, I remember. So Jay Kelly, there's a comment from earlier, said that RISC has always been faster, but than CISC, but they were so expensive. I remember long ago, like in the early '90s or so, seeing ads for RISC architecture trying to sell it, and it didn't catch on. Talking about how much faster it was, but there wasn't the software for it. So today there's software for it. So yeah, it's going to start, and the CPUs are cheaper. So yeah, that's why I think it's really going to just take over. Olaf, was there anything you wanted to show or talk about here?
Well, I believe we basically covered everything that we know until now with the M1s. I mean, again, it's an amazing system, and it's cool to see that even Microsoft took the path down to ARM, and I'm really excited to see the next iteration of the M1 chip design, which is probably going to be shown by Apple in this fall when they have their typical hardware event, September or October. So when I got my MacBook Air as a replacement, of course, I Googled a little bit to see which hardware would be better to use, Mac Mini and iMac, or even a MacBook Pro 13 inches. And comparing money-wise and performance-wise, I decided to go for the Air, and I was pretty neutral in the way in my expectations. But when you see that thing running, it's not just close to what you see and what you read on Mac Rumors and wherever they posted things about the new M design. It's really something new. It's still. I mean, I'm sitting here for the last 2 hours or so, and this thing is just hand warm. No fans are blowing, and now that we see that even Delphi, without any modification, can actually run on it, and in a performance level on a performance level which is at least where we expected it to be. I mean, on a Intel design, there is so much potential still when we compile directly to the ARM design or ARM platform. So there is, in the next couple of years, we can certainly see even more exciting improvements here. So that's what me still blows away.
Yeah, so I can't find any more updated news on the Qualcomm Snapdragon box for Windows, but I would expect, and we just saw Windows 11 just dropped this week, and Windows 11 ARM just dropped today. So I would expect maybe in the next couple of weeks we'll see the Snapdragon box from Microsoft.
Yeah.
Sorry, I interrupted you again. Is that it?
Yeah, DSC alpha processors, of course. There were quite a lot of processor designs, alternative processor designs during the last, 20 or 30 years. And I believe the ARM design somehow showed that it has the perfect, or not the perfect, but it has the best mixture, or it's best compromise between performance, complexity in terms of complexity in the facility where you produce the chip, and the way how you can design your own chip, like Apple and others did. So even if there are kind of exotic designs, like Chris mentioned the VLIW processors, which are interesting because they have a design where every single instruction is technically executed in just a single clock cycle, and these designs never got that successful because they were usually too expensive to produce. They had too much bad output in the facilities. These are the reasons why certain designs never took off in that way. They have probably somewhere a niche market, that's possible, but in the end, it's now getting very close for the older Intel design, or not the Intel design, for the x86 design. It like we talked about previously, where they started to improve, or trying to improve, that old design by introducing RISC designs into that originally being a CISC design, and introducing that microcode that basically built the foundation for the complex instructions. That means basically they introduced somehow a layer to participate from the advantages of having a reduced instruction set, and trying to translate that to their complex instruction set. And that's something they found how to improve the performance, but yet it's technically an emulation layer, or whatever you want to call it. So that's the reason why this will never be that successful as the ARM design, which is based on a reduced instruction set, and it doesn't even try to introduce a complex instruction set on top of that. So it's going to be a shift, like you said before, Jim. We probably will see more and more ARM designs out there. Basically everybody has already an ARM processor in their hands. It's on the smartphones. There is almost no Intel-based smartphone or Android phone. Yeah, they tried it, but it never took off. So, like I said, we're gonna see ARM.
So Chris is saying now we need an OS that abstracts the hardware from applications. Wasn't that the purpose of the Java machine? So actually, we have that now with the browser. This was the way back early internet. They're saying how the internet's going to become the new OS, and realistically, it is today. Is that there's a lot of, I can't think of how much or so much stuff I do. I use Google Sheets, Google Slides, Google Drive, Google Doc all the time, and those are all browser based. And it doesn't matter what device I'm on. There's a few applications. Obviously, Delphi is one I use that is native desktop application, but more and more stuff I do is browser based. So that is, and then something that we're seeing quite a bit of outside the US, not as much inside the US, is the rise of the chatbots in as being the interface for things. And actually, in the US, we're seeing it in the way of through our smart devices like Google Home, Amazon Alexa, and Siri. So, for example, you can order a pizza through your smart device or through a chatbot. And that's really the same interface, just a different way of getting to it. And so that's kind of the next layer that we're getting to of layer of abstraction for the operating system, if you will. So it won't be so much what OS you're running, but you will just connect via a smart client, a chatbot, to these cloud-based services. And so we're seeing that, and that's happening. It's always interesting that these things come in when we see something is coming, right? It's that what is it called? Gartner curve of technology adoption. That's what it is. The hype cycle, that's what it's called. So this is what happens is you see peak of inflated expectations, right? We hear about how blah, blah, blah is going to change the world. And then we're like, oh, it's here. And then, so, we all bought our, or at least I bought my smartwatch a few years back when they were first introduced, right? And, then they're in your junk drawer because they didn't quite work out. But then over time, they iron all those deep bugs out and hits the plateau of productivity. But then the interesting thing that happens is usually when the product arrives here, we forgot about it being here. So artificial intelligence, the GPT-3, actually GPT-2, was doing the things that we said would never, artificial intelligence would never or not happen for a long time. You look at Google Deep Dream. So if this is something you probably remember, if you saw Short Circuit, the way that they decided Johnny Five was sentient is he put the soup on the paper and folded it in half and showed him the ink blot effectively and said, "What do you see?" And he's like, "Oh, it's soup." And he's like, "Oh, clearly you're not intelligent. You're not aware because you can't see beyond the soup." And he goes, "But it kind of looks like a bird or a blah, blah, blah." And they're like, "Oh my goodness, he can see beyond it, that creativity." That's what Deep Dream was doing. It was showing that computers can now do that. And so now they can do these things that before we were saying was pure science fiction, but we're like, oh, well, that's not really artificial intelligence. It's not really what we wanted. But that's what's happening. And so we have this OS abstraction. We have this artificial intelligence. We have a lot of the things that we thought wouldn't arrive in our lifetimes are here now, but we've moved the bar of what we expect those things to look like. Anyway, all right.
Yeah.
Oh yeah, Transmeta. I remember them.
Yeah, the Crusoe processor was it? They didn't live for long, but I remember it.
Yep. So Chris is saying browser-based also means to be connected. That's true, but they are. There is offline apps that you can do as well. So
Yeah.
For example, you can Google Docs and Google Gmail, you can set those up to work in offline mode on your laptop. And if you set it all up right, you can open your laptop on the airplane and have, of course, a snapshot of your email and of your documents there and work with all of them as if you were online, but not actually updating into the cloud and not actually being online. And then when you arrive and connect to the Wi-Fi again, it will then synchronize back up again. So you can have browser-based applications that work offline. I'm still a fan of native applications. There's a lot of applications I use that are browser-based that I'm like, why isn't this native? It's so frustrating. But browser-based is definitely here and definitely very viable and useful.
And think of Electron apps. Like I think one of the most important ones right now is Microsoft Teams. It's an Electron app. And technically, it's a web browser application. They translated it through the Electron framework to run natively.
Yeah. Actually, they announced in Windows 11. That's one of the other Windows 11 things is that the Windows 11 is going to they're taking Skype out as being automatically installed, and they're going to replace it with Teams being automatically installed. And Teams is now moving away from Electron to effectively Microsoft's own version of Electron based on Edge. So I can't remember what their term is for it, but they're making basically Electron, except it's Edge powered, which Edge is powered by Chromium, just like Electron. So basically it's their own flavor of Electron. We'll see how far that goes, but I thought that was kind of interesting development. Okay, I'm just going to check if there's any questions I've missed. I guess natural language interface. Is kind of that Intel. All right. Well, thank you everybody for joining. This has been a lot of fun. I like these where we just kind of sit down and figure things out. You know, I did a lot of prep ahead of time to get all this stuff set up and exploring things, but then things went a different direction because it updated. And we have a lot of great other content coming in the future as well. I'm actually pretty excited about the Docker and the BitChain or blockchain one NFTs coming in the near future or in the next couple weeks. Soon. So beta, I'll say soon. I'm not going to say anything more than that. What soon means to you is subject to interpretation, obviously, but getting ready for the beta right now would not be too early, but don't plan on it arriving imminently. Yes, can compile and run Android apps. Can't run apps. Sorry, so you can't run Android apps on Windows 11 yet. Although, from what I read, you couldn't. This obviously updated, so maybe, but I don't know how to set that up. All right. Well, tell your friends to join next time for Tea, Coffee, and Code. So interesting, Chris's comment about browser-based means to be connected. So yes, the browser works offline as well. Reading your email on the airplane should still be online real time because you're in the cloud. Yes, true. But it's interesting also the browser-based means to be connected, but really most desktop applications anymore assume some degree of connectivity because we're really in a always online world with desktop applications assuming you're online. So much stuff's browser-based, and so much stuff is also even mobile apps assume that they're always online because mobile devices are almost always online. And that's kind of the result of that is that the mobile, right? Mobile really changed that, is that so many apps were on mobile were always assumed to be online.
Yeah, it's I believe even that many software producers don't even really test their applications anymore in real offline scenarios. If you are on an airplane and start an application just to see something that you already read in that application, you often see applications not responding at all anymore. So yes,
Yeah,
the
it is.
smartphones.
Go ahead.
Yeah, the smartphones changed the way how we interact with the well the cloud and connectivity.
Yeah, it is important that you do make sure your software works offline, both um,
Yes.
when possible. Obviously, there's going to be reduced functionality for some things, but web-based apps should be, if they're serious ones like Google, the Google Suite should make sure they work offline, and desktop apps and mobile apps as well. They should have some level of offline functionality when possible. It's actually been surprising how often I've had um, software that I wouldn't expect to require to be online, that I'll be in airplane mode on my phone or something like that, or my desktop, and it'll just be like, sorry, not working. I'm like, what? I didn't even know this was online. What the heck? So, Olaf, there's a
Yeah.
question here. You're running a MacBook Air, right?
Yes.
And you're running Delphi on it just fine?
Yes. I'm using a newer version, if you will, and it's just running fine here. So, like I said before, I just reduced the resolution or the scaling on Windows from 200, which was the default, to 100, and it has a resolution of 2600 by something. So depending on your site, it's a lot of screen real estate on even the 13-inch screen. So yeah, technically it's just working like yours. The only difference is I can't upgrade to Windows 11 right now. Might
So
be
you
a
might,
parallels issue.
so you need to go in. I'll show you what I did. Um, is if you go into, it's going to be different because this is now Windows 11 settings. You have to go into Windows Update, Windows Insider Program, because the default
Yes.
one they give you. Oh, I still don't meet minimum requirements for Windows 11, even though I'm running Windows 11. Interesting. So anyway, I had to go in here and log in and choose the dev track to see I'm logged into the Windows Insider Program. By default, it's not.
Yes.
So you might need to do
Yeah,
that.
I did that already, and on my screen it says your PC is does not fulfill the minimum requirements for the hardware. So it's something that prevents me from upgrading to 11.
Hmm. Yeah.
It, it could be that I installed Parallels as trial first and got my license after I installed Windows. So it could be that Parallels is running in a still in a reduced mode or something. So I will reinstall Windows and see if that changes something.
That's how I installed mine too. So not sure. I
Because
was
when
totally
you
surprised
start,
it happened.
yeah, yeah, when you start a new virtual machine with Parallels, it's asking you what's the purpose? Is that gaming, office, or development? And development was grayed out for me, so could be something in that direction.
Yeah, it could be. I'm trying to remember. I don't remember. I've been so many different things I've been doing. I don't remember exactly the process I went through, but yeah, it was. I'll experiment with it again and see what I can figure out. But So there's a question here about Windows 11. Could we run and debug Delphi Android apps directly in Windows 11 environment? I would say I would expect eventually. I'm not sure how that's going to work, but I would expect that you totally should be able to do that very near future. Windows 11 isn't released yet. The Android functionality isn't even in the insider preview yet, and it's not something that's currently on our roadmap. But things happen, things change. Windows 11 was a surprise that they were changing. I mean, we knew they were working on new stuff in Windows, but it wasn't until fairly recently we knew that it was going to be considered a whole new OS. So, yeah, I would expect it should eventually work, though. Cool. All right. Well, thank you so much, everybody, for joining us. Thank you, Olaf, for getting on. Sorry I didn't see your message earlier about that. And running,
No problem.
making things up as we go along today.
Quite interesting. Yes. Thank you for listening, everybody, and hope this was somehow interesting. Yes.
I found it really interesting. I learned a lot today.
Yeah. I mean.
All right. Take care, everybody, and we'll see you online next time for the next Tea, Coffee, and Code. Bye, everybody.
All right. See you. Bye-bye. Bye.